going to be our next notes. We're going to start on Chapter 6 now, and this is going to be on quadrilaterals. And really, a quadrilateral is a polygon. And you can see here the definition of polygon. It's a figure within a plane with at least 3 sides and angles. So we've really been looking at triangles. But we're going to really branch out here. But in the end, you're going to notice we're like taking these ones that are not triangles and then making them into triangles. And then using some of the theorems and such that we've already learned and adding a few new ones. And especially this chapter, we're going to be looking at angles and how we can figure them out and how they're related to each other and so on. The first thing that helps us understand that is something called a diagonal. And a diagonal is a segment that connects any 2 non-consecutive vertices. And a vertices is just a place where 2 lines meet, and this would be an angle and an angle and an angle. And you see here I've drawn these lines in, and those are the diagonals. So if we have this pentagon with 5 sides, 1, 2, just number 1, 2, 3, 4, 5, we can then draw a segment, a line, between any 2 non-consecutive vertices. So here we have PS, right? And then we have PR. We couldn't have PQ because it would be a line we already have, and we couldn't have PT, it's a line we already have. And we could go like TQ and TR, okay, but it wouldn't be that much different than what we already have. So here you can see the diagonals are PR and PS. Okay? And you really should notice, like I said, they form triangles. So we have a triangle right here, we have a triangle right here, we have a triangle right there. And then we can use those later on, you're going to see, to determine and find out stuff we already or don't know about these quadrilaterals and polygons in using some of the things we know about triangles. So, but because they form triangles, and they kind of do it in kind of like a pattern. So let me show you this down here. If you have a triangle, it has 3 sides, and that triangle is composed of one triangle. And we should know that the triangle, the total angles within there equal 180 degrees. If we then look at a quadrilateral, and we form those diagonals, we remember that a quadrilateral has 4 sides, but we can put 2 diagonals in there, or 1 diagonal, sorry, and then it would form 2 triangles. And then a pentagon, which we just looked at, it has 5 sides. We could then put 2 diagonals, but form 3 triangles like we did here. 2 diagonals and 3 triangles. And then we would figure out these 2. If you see over here, let me bring that up a little bit. We would know that depending on how many triangles we have, we just multiply that by 180, and that gives us the total degree of that figure. So quadrilaterals have 2 triangles, so they're equal to 2 times 180, or 360. And then pentagons have 3 triangles when we put those 2 diagonals in there. 3 times 180 equals 540. So that's kind of the first thing you want to realize, that we can divide these figures up into different shapes or different triangles by doing these diagonals. So here's a square, right? So we could do 1 through there, and that would then give us 2 triangles, and that would be 2 times 180, or 360. And we know that, right? 1, 2, 3, 4 angles going to give us 360. And like we did down here with the diagonal, we could go there and there. We'd see 1, 2, 3 triangles. So 3 times 180 gives us 540, and that's how many degrees is in that polygon. So then we have a theorem for that, and this is called the Polygon Interior Angles Sum Theorem. Okay? And this says the sum of the interior angles of an n-sided convex polygon is equal to this equation right here. So the number of sides minus 2 times 180. And really the number of sides that we have, we just minus 2, that, and then tells us how many triangles. So 5 minus 2 gives us 3 triangles. 3 times 180 gives us whatever angles we need, whatever angles it would be. So here you kind of see the example. It has 5 sides. We go 5 minus 2. That would be 3. 3 times 180 gives us 540 degrees. And that's how we'd use that. So we just use this basic equation. and we can figure out the different total angles of each different polygon. So then if we do an example, here's example 1. So I have this shape here, heptagon. It has 7 sides. We can count them 1, 2, 3, 4, 5, 6, 7. And we could use this formula, but first let's just see what they all are. If we took 87 and 140 and 145 and 128 and 130 and 136 and 134 and 87, now add them all up together, we would see that they're equal to 900 degrees. And we might say we're using some of these and we're trying to figure out, well, does this really, do the angles that we figured out, do they actually equal the angles that they should for this amount of sides? So this has 7 sides, so then we would take that and plug that into n minus 2 times 180, 7 minus 2, and times 180, that'll be 5 minus 180, minus 5 times 180, and that'll give us 900, and then those two match. Okay. So, yeah, that's how you do, that's one example of that. Another example is a little bit more difficult. Okay, let's move this down a little bit. So, this one doesn't have just numbers, it also has unknowns. And we're going to plug in algebra to this and see if it comes out like it should. So here we have this quadrilateral, and we have an angle equal to 3x. We have a 90-degree angle, another 90-degree angle, and then we have x. And we know it has 4 sides, so if we plug in to that theorem we just learned, 4 minus 2 times 180 would be 2 times 180 will give us 360 degrees. And that should make sense to us. It's like a square, right? It has 4 sides. We could divide it into 2 triangles, right? So it would be 180 and 180, 360. Okay? So we keep that in mind when we're trying to solve for this and this. We set this up in the following way. So we just plug in each variable. We have 3x this angle, plus the angle x, plus these 2 90s. That will give us 360. We then collect like terms, 4x, and we add these 90s, plus 180 equals 360. And then we're going to minus 180, gives us 4x equals 180. Divide by 4, and we get to our angle x equals 45. Okay. Then we could plug it in and see if it works, and you would find that this is 45 up here. Let's see if I can draw that a little darker. 45. This is 45 times 3, it's 135. And these are 90 and 90, 180. So if we just did the math, 180, 135, and 45, we get 10, we get 16, 360. It's right. Okay, it's always good to go in and check those to make sure you got them right and correct. So we can also use this interior angle sum. If you have a triangle, if you have a polygon that has equal angles, you can just use that same formula, n minus 2 times 180, and just plug it in. And you just down here, here's the equation. So the sum of the interior angle measures divided by the number of congruent angles. So if these sides are all congruent, that means the angles are congruent. So we would then take the 6, use this formula, 6 minus 2 be 4, 4 times 180 be 720 degrees, and then you just look at number of angles. That would be 6, because we have 6 sides, 6 angles. If you move this down, so we divide by 6, and we would get 1, 2, 120 degrees each angle. Okay, that's kind of how you can use the formula to figure out what an angle would be if all sides are equal. And if we have one more thing, so we have one more theorem here, the polygon exterior angle sum. So and what this theorem says is the sum of the exterior angle measures of a convex polygon, that's with one angle at each vertices, is 360 degrees. Okay, so doesn't matter what it is, like a triangle, whatever it is, those angles, if we add them all up, they're going to be equal to 360 degrees. So if we look here at this triangle, this outside angle here, exterior angle is 100, this one's 120, this one's 140. They're always going to be equal to 360 degrees. So we can use this theorem to solve for unknowns when we have like something with an x in it. So here we have this, how many sides? 1, 2, 3, 4, 5 sides. Okay, and then we're going to figure out, use the fact that these are all these exterior angles, we can then add them all together and make them equal to 360, and then we can figure out what each angle is equal to. So if we use algebra, let me move this up here. I'm going to cover this up a little bit. So I'll take each one of these sides, 3x plus 10, move this up maybe a little bit. 3x plus 10 plus 2x minus 5 plus 5x. And then we have plus 6x minus 5. We make that whole thing equal to 360. Then we collect like terms. So we got 3x, we got 5x, we add those together. Then we got 10x, 12x, looks like 18x. And then we do these plus 10, and then we got minus 5, so it's 5. And then we have minus 5 is 0. So we got 10 minus 5 is 5. And then 5 minus 5 is 0. So then it comes out to be 18x equals 360. We're going to divide by 18. And then we do the math here. And we get x equals 20. Then we can then take that answer back. X equals 20. We can plug it in. So 2 times 20 is 40 minus 5. This should be 35 degrees. And then we have 3 times 20 is 60 plus 10. This should be 70 degrees. Then this one is 20 times 6, 120, minus 5, 115 degrees. And then this one should be 2 times x, should be 40 degrees. And then this is 5 times x is 100 degrees. And then if we add them all together, we should see that they equal 360 degrees. So we got, let's see if we can do it real quick in our head. 100 plus 35 is 135, plus 70 is 205. So 205 plus 40 is 245, and then 245 plus 115 is 360 degrees. So that's kind of a useful theorem, the polygon exterior angles sum theorem, so keep that in mind. And that should cover us for the first notes for 6-1. Make sure you add these to your notebook, and you'll be ready to go in class on Monday.